This time you take the 2's complement, 2's comp of 12. I will have loaded 27 into the accumulator, so anyway, I'm just going to say add the accumulator with the subtrahend. So that's, this time we've got 27 in it, and this has got the effectively the minus 12 or whatever. If carry equals 1 sub 1, and then invert the carry. And that gives you your final result, whether it's positive or negative. So it's a very tortuous sequence of steps that's going through, but that's the operations. Now we're going to do those steps for the next few minutes. We'll leave in a little bit more detail and see if we end up with the right answer. All of this is captured on those slides. So what's in your hand now? So you've got the kind of rules all written down for subtraction. And again, it's written here about all the steps that's going through, but and then you've actually got the worked example here. So let's see what we've got. So in the first step, this was the we're taking 96 from 62. So this is what 62 is in binary. This is what 96 is in binary. And you can check that this is the 2's complement of 96. Okay? You just invert and add 1, and you should end up with this number. Okay? And then you perform the addition of the things in the accumulator with the 2's complement of the subtrahend. So because we've done the 2's complement of the subtrahend, we've turned it into effectively a negative number, and we're adding the negative number to the positive number, which is just the same as doing a subtraction. And we also cleared the carry flag. You should end up with this result, okay, when you perform the addition. And there isn't a carry out, but we know it's a negative number. And one of the steps that we had was, where is it? Invoke. Was there a carry out? Don't think so. No. So, it wasn't a carry, but this step, invert the carry. So we've changed the carry to a 1. We then perform the second operation, leaving the carry in its current state. So, 27 is this number, and then we're taking 12 away from the 27. So to do that, we're basically turning plus 12 into its negative equivalent by turning it to its 2's complement and then performing the addition. So if that's plus 12, this is the 2's complement of plus 12. Okay? So you just invert it and add 1, and you should end up with this number. And then we just add those two numbers together. So this is the same, this is just this number brought down here, performing the addition. So we then do this addition, which actually will result in a carry. Let's put that to one side for a minute. Before that happened, CY, because it was 0, we changed it to a 1, so there would have been a carry in associated with this. So we need to take away 1 from the result. Okay? So it's this because of this step here. So as the carry is a 0, where are we? We've inverted the carry, which made the carry a 1. And in the second step, when you're performing the addition of the first number with the inverted subtrahend, after having done that, you subtract 1 from the result. And so you'll end up with this number. So the difference between here is we've taken 1 away. We took that 1 away because the carry had, having inverted it, had become high. And so we ended with this number, which when you convert it, leaves you with 14 hexadecimal. Now, the final step is that the proper carry at the end of it, we invert it, and there was a carry out, remember, as a result of this, which would have made it high, but we're told to invert that, which makes it low, and then it says, okay, having done that, is the carry high or low? And because it's low, we say, oh, the result's positive. So what it's saying is this 14 is a positive 14. So very kind of convoluted sequence of steps here. Okay? So it will actually give you the right result. So in the first step, first of all, we're clearing the carry flag. It's all, the complexities with the carry flag, it has to be said. Everything else is pretty straightforward. But in the first step, we're clearing the carry flag. We're doing the 2's complement of the second number, and then just performing an addition. And then depending on the state of the carry flag, we have to make an adjustment. So if the carry was 1, we need to subtract 1. It wasn't in our case, so we didn't do that step. Having whatever happened, we then invert the carry, which is what we did do. And then, okay, that's step 1 dealt with, then we deal with step 2. Step 2 starts off nice and straightforward again, just like the previous one. And in the second step, first of all, the second number, we just take the 2's complement of it to turn it into a negative equivalent, and then perform the addition, which is what we did here. But we also take into account, having done the addition, if the carry was set, we remember to take 1 away.
What do you take 1 away from?
Sorry?
Do you take 1 away from the carry, or from?
No. From the result in the accumulator. If the carry had been set before, because we had carry 1. Now it wasn't actually 1 when we started. Remember when we did this, we inverted the carry at this step. We made the carry 1. So when we perform this addition here of what's in the accumulator together with the 2's complement of the second number, having done that, we end up with this number, which is actually an 8-bit number here plus a carry out. But we remembered that the carry was previously set anyway. And because the carry was previously set anyway, this number's in the accumulator, we take 1 away from it. So that's why that number is going to go, and we're left with that. So that's that bit. Yeah?
May I know why the carry is 1 at the second case? Is it because 62 is less than 98?
Yes.
Or is it because the previous one, we changed the carry 0 to 1?
The carry...
at the step 1, the final step is invert carry.
Yeah.
Carry at first is 0, and we invert it to 1.
Yes.
So we keep the 1 to second step, or
If we had a number here that was smaller than this, well, the end of the first step is whatever the carry is, we invert it. And effectively, that's because the second number happens to be of larger magnitude than the first number in this case. You could try it with a number where this is smaller than that, so there is no need to borrow. And what I would hope you'd see is effectively you'll probably end up with a carry here that when you invert it, it will actually cancel it out. But, we can perhaps try that. But I'm not going to do it just a minute because we've got a minute or two to go. Yeah.
Right. There's only one carry flag, right?
Yes. So it's going to have to, in this particular case,
so they're both for
it's
the
going
same
to have to use it
one.
once and then use it again. So. So generally, in summary, this is the steps of the sub. So it's take the 2's complement of the second number, add it to the accumulator. That's all straightforward. If the carry happens to be set, subtract 1. If it's not set, don't do that step. Whatever happens, invert the carry at the end of that step. And that's it. That actually, at the last step, will actually tell you the results, positive or negative. Now we could try another one tomorrow with a different kind of number where we'll maybe have this smaller than this and see what happens. Yeah? Okay. So, you would be expected to know, we've only got a minute or two left, about things like BCD, binary coded decimal, addition, and what the DAA instruction does, decimal adjust accumulator. So we did that first today. You'd also be expected to know about straightforward addition, not BCD addition. That includes multi-byte addition, how to do that. If you're doing multi-byte addition, remember from the addition of one step, you're going to have to store the results of the carry flags in some register somewhere that's going to become the most significant byte, so to speak. And we've got a lot of examples of that. We did addition of 5 numbers and things like that a few weeks ago. We also have seen how to add up multiple BCD numbers. And again, we use the carry flag, we store that in a register somewhere, and that becomes, the, if you like, the most significant byte, the hundreds or whatever. In terms of subtraction, I've shown you some very simple steps in subtraction, first of all, where we did, for instance, things like -9, -7, all that kind of stuff. And that was all straightforward. Okay? And in that case, all we really had to do is the second number that we're doing the subtraction is to take the 2's complement of it and then perform the addition. For multi-byte subtraction, life becomes a lot more painful. The pain is not with the kind of the subtraction operation in itself, it's about how to manipulate the carry flag. About the steps that you do with the carry flag at the end of the subtraction of a particular stage. And there are rules of how that should be handled to make sure that the kind of the borrowing and the payback is all done properly. So we've done one example, which is the one which is in the notes, but tomorrow we'll quickly start by doing one more example, which is not in your notes. I'll work out another one today, where, for example, we'll make this number smaller than that number. And we'll apply the same rules, and hopefully I can convince you that it does actually work. All right? Once we've done that, we're going to very briefly do signed numbers, and about the use of the overflow flag. And then having done that, we're going to do very briefly a little bit about bit manipulation. There's about 4 slides on that, and about ports. And then once we've done that, we're pushing it all to one side, and then we're going to spend the rest of this week talking about timers in a lot of detail. Okay. So see you tomorrow then.